Hi, this is Mr. Warden. This is your video key for Geometry Exit Ticket 28.2, and let's take a look at what we're dealing with. So, as you can see, I'm introducing a theorem, Theorem 58 here, that will pop up for you in Chapter 8. You may have already run into it if you've already started Chapter 8, but I like to preview things for you so that when you get there, it'll be easier. So Theorem 58 simply says, if three or more parallel lines have two or more transversals going through them, so like here I've got three transversals going through these three parallel lines, A, B, C, D, and E, F. Those parallel lines divide those transversals into proportional segments. So that means AC is to CE as AG is to GF, as BD is to DF. Or AC is to AG as CE is to GF, or AG is to BD as GF is to DF, or even AC is to BD as CE is to DF. So all of those can be used to form proportions. So you can use this to work out problems using proportionality, which is the big theme of Chapter 8, proportionality. So we're going to use the ideas from Theorem 58 to solve for y. So we know that line A, B, and C are all parallel. The lengths are shown, so 4 and 9 and 6 and something or other. So what we need to do is figure out what the something or other is, what y is. And we can just create proportions. I can say 4 is to 9 as 6 is to y, or y is to 6 as 9 is to 4, or y is to 9 as 6 is to 4. All of those will work as proportions. So here, let's do that. So let's say y is to 6 as 9 is to 4. Okay, and then we'll multiply 9 and 6, and you'll end up with, and we'll multiply 4 and y, because the product of the means is going to equal the products of the extremes. So 4y is going to equal 54. And then we just divide 54 by 4. So knock that off, that divided by 4, and that's going to end up being 27 over 2, which will end up being 13.5. So y will be 13 and a half. So I'll set it up right here. So you've got y over 6 equals 9 over 4. And then I can say 4y equals 6 times 9. So 4y, let me actually scroll down a little bit so you can see what the heck is going on. So 4y is going to equal 54. And so y will equal 54 over 4, which is going to equal 13.5. So that's your answer for y. Now, the next one's a little more proofy, so let's take a look, but it's still basically the same idea. In this case, we're trying to prove that MO is to OP as MT is to SR. Well, we know OS is parallel to PR. Okay, and what that tells us is that we have actually got we've got parallel lines. Actually, we probably won't be using 58 as much as just the ideas of similar triangles here. So what we definitely know is that MO, I may actually not do that. We go back, we get the eraser. So we know that MO, let's just go ahead and start typing in here. So we know that a couple things. So the givens, let's start off with the givens. OS is parallel to PR. So we know that. So this is OS and PR, they're parallel. And we know that, and this will be really important, angle 1 is congruent to angle 2. Okay, and that, by the way, is going to tell us, those are givens, of course, given and given. Later on, that tells us, by the way, that TSR is an isosceles triangle, which tells us also that TR and SR are congruent. That's a key element of this because it's easy to prove that MO is to OP as MT is to TR. It's not as easy to prove MT to SR. But if SR and TR are the same, because that's an isosceles triangle, it'll be easy to do. Okay, so now we have this parallel line, and we know from previous stuff that a parallel line, a line that is parallel to the base, it cuts through a triangle, and it's parallel to a side of the triangle, is going to intersect the other two sides in such a way that it splits them into proportional pieces or proportional segments. So because these are parallel, we know that so we can say that MO is to OP as MT is to TR. Okay. We also know that TSR is isosceles. I should give a reason here. Triangle MPR, not MPR, is cut by a line, a parallel line, or a line parallel to its base, and that divides its other two sides into proportional segments. Okay. Fix the spelling of isosceles there. So triangle TSR is isosceles. And we know that because angles 1 and 2 are congruent. Definition of an isosceles triangle. Okay, now, because of that, we know that TR is congruent to SR by definition of an isosceles triangle. Okay, now we can say that MO is to OP as MT is to SR by substitution. We're just substituting, or we're substituting SR for TR. Okay, and that's really all we needed to do. I hope that helped.